end of chapter questions under the use of coordinate. Coordinate and y coordinate of the point of intersection of the two axes. The point of intersection of the two axes, that is the x and the y axis, is called the origin, and it has the x and y coordinates as 0, 0. Point W has x coordinate equal to -5. Can you predict the coordinates of the point H, which is on the line through W parallel to the y-axis? Which quadrants can H lie in? This is the question. What information have they given? They have mentioned about 2 points. One is point W, for which the x coordinate alone is given. The y coordinate is not mentioned. So the y coordinate can have the values minus infinity to plus infinity for point W. Now we have one more point, which is the point H. So the point H can lie anywhere on this line. This line is nothing but the line which contains the point W, which is parallel to the y-axis. So the point H lies on this particular line. What question have they asked? Can you predict the coordinates of the point H, which is on the line through W parallel to the y-axis? So we need to predict the coordinates of the point H. Since W and H are on the same line, which is parallel to the y-axis, the x-coordinate of H is the same as the x-coordinate of W, which is equal to -5. What happens to the y-coordinate of H? It can range from minus infinity to plus infinity. Minus infinity from the y dash to plus infinity along the y-axis. The y-coordinate can have any value. So it can have, the y-coordinate can also have the value equal to 0, in which case the coordinates of the point H could be -5, 0. Otherwise, it can have any value which ranges from -5, minus infinity to -5, plus infinity. Now let's look into the quadrants where the H can lie in. We all know we have 4 quadrants: quadrant 1, quadrant 2, quadrant 3 and quadrant 4. Looking at this graph, we can make out that the point H can lie either in the second or the third quadrant, or on the x-axis if the value of H, if the H lies on the x-axis. Now let's move on to question 3. Consider the point R. They have given some 4 points. If they are joined in the same order, we need to predict. They have given a set of 3 questions based on the information given. I've just plotted the points on the graph R, A, M, P. Joining each one of these points results in a polygon, as you can see very well in this given figure. Now, first question is two sides of RAMP that are perpendicular to each other. Perpendicular is any two sides of the polygon that meet at 90 degrees or at right angles are perpendicular to each other. So we can make out very well that the sides MA and PM are perpendicular to each other. Question number 2. One side of RAMP that is parallel to the axis, to one of the axis. We know the two axes, x-axis and the y-axis. Now the side which is parallel to the x-axis, which is the x-axis, this is the x-axis. The side which is parallel to the x-axis will be AM. Now which is the y-axis? This is the y-axis. The side which is parallel to the y-axis will be MP. Now let's move on to question 3. 2 points that are mirror images of each other in one axis. Which axis will that be? 2 points, they are mirror images, meaning if you consider the 4 points as given in the question R, A, M, P, if you plot and look into the figure, we can make out very well that M and P are mirror images to each other. With respect to which axis? With respect to the y-axis. If you consider to the x-axis, if you consider this x-axis, the point P is at equidistant from the x-axis. The distance is the same between the x-axis and the point M. Z with the coordinates 5, -6 on the Cartesian plane. construct a right angle triangle IZN and find the length of the three sides. So we need to construct a right angle triangle, right angle at Z. So the point I have chosen are I 5 comma minus 1 and n 7 comma minus 6. Joining the points, we can construct a right angle triangle IZN. Now the question is, how do we find the length of the sides? This particular construct of the triangle is very simple, wherein I have just constructed a right angle triangle with two sides, one of which is parallel to the x-axis and one of which is parallel to the y-axis. The side which is parallel to the y-axis is zi. So the difference between the y coordinates will very well give the length of the side zi. Zn is parallel to the x-axis, so the difference between the x-coordinate of z and n will give the length of the side Zn. How do we find In? This is the only side which is left out for this particular triangle. This we can find out by using the Baudrillard-Pythagoras theorem. We know the theorem very well. The length of the hypotenuse is equal to the square root of the sum of the squares of the other two sides. So based on that, we can very well find the value of In as mentioned in this particular line. So only the value of the coordinates of Z are given. The coordinates of I and N we are expected to choose as per our convenience. I have chosen these 2 points. So the values of I and N could be different also. It need not be parallel to any of the axes also. But the only constraint which you should consider is it should form a right angle at Z. So based on that, as we have seen in the previous exercises, if it is not parallel to any of the axes, once again we need to find the length of that particular side by using the Baudrillard-Pythagoras theorem. Let's move on to question number 5. What would be a system of coordinates be like if we did not have negative numbers? Would the system allow us to locate all the points on a 2D plane? This is a sample construct of the 4 coordinates of the 4 quadrants. First quadrant, all the values being positive, meaning the x and y coordinates have positive values. The second quadrant, where the x coordinate will always have negative values, the y coordinates always have positive values. The third quadrant, wherein both the x and the y coordinate have negative values. The fourth quadrant, where the x coordinate is positive and the y coordinate is negative. Now, if we do not have the negative numbers, we can identify or locate the points only on the first quadrant. So what would happen? How do we locate the points which can fall on the second, third or the fourth quadrant? It is not possible. Since a 2D plane, it extends indefinitely on both directions, all points cannot be plotted on a 2D plane if there are no negative numbers. Are the points M with the coordinates minus 3 comma minus 4, A 0 comma 0 and G 6 comma 8 on the same straight line? Suggest a method to check this without plotting and joining the points. What they have given is we are not supposed to draw any graph and plot any of these points, or by joining any of these points we are supposed to find if all the 3 points can lie on a straight line or not. We can make use of the formula to find the distance between the 2 points x1 y1 and x2 y2 as square root of x2 minus x1 the whole square plus y2 minus y1 the whole squared. So using this formula, substituting the values of m and a, we get the distance between m and a to be equal to 5 units, distance between a and g as 10 units, distance between m and g as 15 units. From the values, we can make out that MA plus AG is equal to MG. According to Pythagoras theorem, MG is equal to square root of MA squared plus AG squared. So it satisfies the given condition. MG is 15 and the value of square root of MA squared plus AG squared is also 15. Now, the length of the hypotenuse is equal to the sum of the other two sides. So we can make out that the point MA and G lie on a straight line. Only then the length of the two sides will be equal to the length of the distant 2 points, like MA plus AG. A is the point in the which lies on the straight line with M and G as the endpoints. Since MA is equal to AG, we can say that MA and G lie on a straight line. Points R, B and C lie on a straight line. We use the same formula as we did in the previous sum and find out the distance between R and B, BC and RC. Now we infer that RC is not equal to RB plus BC. There is a minor difference, a very small difference between the values. When we plot the points on the graph, we can see that the point C is not lying on the straight line. So we can conclude that the points R, B and C do not lie on a straight line. 8. Using origin as one vertex, plot the vertices of a right angled isosceles triangle. Let's look into a definition of an isosceles triangle. Isosceles triangle has two sides which are equal and the angle which is embedded with the other side are also equal. The two angles are equal and two sides are equal in an isosceles triangle. What happens in a right angled isosceles triangle? The two sides are equal, the two angles are equal, and the two angles should be equal to 45 degrees. Since it is mentioned it's a right angled isosceles triangle, the third angle should definitely be 90 degrees, making the other two equal angles 45 each. Now, the question number 1 is right angled isosceles triangle we need to construct with the vertex as the origin. So, as you can see, 0 O is the origin and one vertex will be at O. The other two could be anywhere with only the constraint that the angle should be 90 and these two sides should be equal. This is sum number 1. What is sum number 2? The isosceles triangle with one vertex in quadrant 2 and the other vertex in quadrant 4. So one vertex as the origin is what is given in the question. For question number 2, there is another specification that one of the vertex should be in the quadrant 3 and quadrant 4. So this is how we construct. Kindly make a note that question number 1 insists that it's a right angle. So this particular angle is 90 degrees, whether it is not emphasized. It could be of any value. But the only constraint is these two angles should be equal. Let's move on to question number 9. The following table shows the coordinates of point SM and T. So each we need to find out whether M is the midpoint of the segment ST, and we need to justify if it is the midpoint or why it cannot be the midpoint of the segment ST. If you look into the first set of values, S is minus 3, 0, M is 0, 0, T is 3, 0. By making use of the midpoint theorem, we can choose the 2 points S and T, find the midpoint. How do we find? Just add the x coordinates together by 2, add the y coordinates together by 2, you get a point. That is the midpoint of the segment ST. See if that point which you have derived is the same as M. So the first question satisfies the condition. So M is the midpoint of ST. Now, for the second sum for the given coordinates, once again just substitute the values and find the midpoint of ST as 3, 4. Check the value of this 3, 4. If it is a value of M, it satisfies the condition. So M is the midpoint of the line segment ST for sum number 2. If you look into sum numbers 3 and 4, the same concept of the midpoint of ST will not satisfy or will not be equal to the value of M given for that particular segment. So we can infer that it cannot be the midpoint of the line segment.